My name's Stephen Blowers. I'm a software development engineer at Firmware. This lightning talk is called Creating a Microsoft SQL Server Adapter for Ecto 2.0. It's going to briefly explore technology choices we made to deliver fast and the developer experience of creating an Ecto adapter. So I mentioned that we wanted to deliver this project fast, so we made two key decisions on how the project would unfold. So firstly, we would only support SQL Server features that we needed, and secondly, we would write as little code as possible, trying to compose existing technologies where we could. So this is kind of how I kind of visualized the problem we had. So we're going to look at some of the existing technologies we use to bridge the gap between Ecto and SQL Server. So currently Microsoft is making moves to let their software be more compatible with Linux and Mac OS. So one of the ways they've done this is with the creation of the ODBC driver called for SQL Server. So with that in place, we then looked for a pre-existing library that we can use to talk to an ODBC driver. And we found that in the form of Erlang ODBC, which is part of the Open Telecom platform. So with those two things in place, we've gone from needing to bridge a gap between Ecto and SQL Server's binary format to a smaller gap between Ecto and the Open Telecom platform. So now begins where we actually needed to write some code. So we decided to split our implementation into two separate libraries. One would be a general purpose Elixir driver for working with SQL Server, which encompassed all of the ODBC stuff that I talked about, and the other would be an adapter between that and Ecto. So the general Elixir driver is called MS SQLX. So after looking at similar drivers like Postgres and SQLite, we knew a library called DB Connections where we should start. So this library is a behavior module, and you can think of a behavior module as similar to an interface class in object-oriented programming. DB Connection defines a set of behaviors that, if implemented through callbacks, provides an implementation for database connections, pools, and transactions. So we kind of use it like a blueprint on how we'd build our driver to get the functionality that we wanted. So for the most part, after we had implemented the callbacks, we had a working Elixir driver for SQL Server. So next came the Ecto adapter that we decided to call MS SQL Ecto. So I'm not going to go into any detail on this part, as I think it's quite a well-documented process, and it's pretty similar regardless of whatever database you're going to connect to, especially if it's SQL-based. So instead, I'm going to point you to some user resources that we used for creating the adapter. So firstly, there's this blog post called by Michael Muscala called Creating Ecto Adapters. It's a really good kind of overview of what's involved in creating an Ecto adapter. Secondly, there's the Ecto adapter docs, which you can find in modules starting with ecto.adapters. And also there's the Ecto integration tests. These were great because kind of from the get-go we had this full set of tests that we can use to help understand what to do, how to do it, and kind of understand whether we've done it correctly or not. So with MS SQL Ecto finished, we were able to communicate to our database with Ecto, and the project was a success. So where's the project today? So in terms of hex downloads, we've got about 5,000 hex downloads between both of the packages. We are listed in the Ecto README as an available adapter. And as of Phoenix 1.3, if you run this command, then you'll create a new Phoenix service using MS SQL Ecto and MS SQLX. So where are we taking the project? So at the beginning, I mentioned that we don't fully support all the features of SQL Server. So next comes full support of SQL Server. Unfortunately, the limiting factor is not our libraries, but it's Erlang ODBC. So we'll be looking at trying to put in some pull requests for that, and any help from the Elixir or Erlang community will be greatly appreciated in doing that. That's the talk. Here's the links to the libraries. Thank you.
My name is Krzysztof, don't try to pronounce it. You probably might know me from autocomplete Elixir, which has over 30,000 downloads right now, and a huge title, Project Deprecated, because of drastic changes, which didn't hold you from posting a lot of original issues. A lot of original issues. So I want to present my latest project, which is Alchemy, recently known as Elchemy. It's a long story. So who of you is familiar with Elm language? Okay, so for those that don't know, Elm is like Haskell-ish language that doesn't have type classes. There's a good article about scrap your type classes about why it doesn't have and why it doesn't need them. So Alchemy is a compiler of maybe a language, if you will, that compiles Elm code to Elixir code. And the syntax is the same, the semantics are a little bit different. Right now it has over 100 releases and it's pretty much ready. So I will do some live coding for you, so there is a lot of room for me to make a mistake. So I will show you how it basically works. This version is, you can access this version online. It doesn't do any type checking, but the console version does type checking. So if I make a mistake in here, it doesn't mean that the compiler will let me do it in my editor. There are only parsing errors here. So we can define our module, which is Elixir conf London 2017. On the right, we will see our compiled Elixir code. So we can define a function, Jose's doc, which is an integer, and which is a float, which was 100 on 100. We can write a documentation for it, which would be a talk by Jose. Okay, one more thing. It's a comment, not a doc. So, okay. And Elixir conf first is a module doc. So basically it has everything that Elm has right now. It doesn't have Elm effects, so you can write an entire library in that. And plus a lot of niceties, like for example, how do we test code in Elixir? We test it by writing, oh, the indentation is wrong. By writing duck tests. You can write duck tests inside our code. You can define your own operators. You can, so you can define your own operators. The operator can be anything that wouldn't even be allowed by Elixir. So it can be really anything as long as I can repeat it over there. Okay, that's impossible. Yeah. Okay, so you can also define types, which would be like, for example, the types are tagged unions. So if you're not familiar with the term, I recommend looking it up. So we can have a type Elixir programmer, which can be either Ruby, let's say, or Elixir Erlang. And we can we can obviously use these types. You can match on them. Let's say we can use them in cases. It's impossible in this time. Okay, this is not a proper code. So you can see that if a case is the same, if the case clause is the same as the argument, it will split it to an overridden heads, overloaded. Okay, I'm not gonna make it. There is a lot to it. All of the features of Elm that aren't related to effects are right now implemented. You can do almost everything. Everything is carried. You can just do stuff like map list, and it all will work. You can also do map +1. Everything that works in Elm, it will work in here. I really recommend checking out, not this one, Alchemy.
Hello, I'm Elliott. I make sheep games in my spare time, and I want your help. In the next 2 minutes, I'd like to get everyone to go on the Wi-Fi and go to woolensockets.heroku out. I want to see as many sheep on here as I can get. I've only seen 3 sheep max before, so this is an experiment, and I don't know how it's going to go. I have no idea what's going to happen when we get more, if it'll stop or, if it'll be able to cope. So it's made with Phoenix using channels and a game library called Phaser. There's four main events that happen. There's A player can join, leave, the player needs to send a new position, and there's also the need to, wow, that's a lot of sheep, broadcast a copy of the world to all the other players. So once I got the channels working, then it was a bit of an exercise to try and make things a bit more efficient. So I wanted to talk a bit how I managed to split up the world and then optimize it so that the right amount of messages were being sent around. So we've got 4 basic types of structs. We've got velocity, which has an X and a Y, a position, which has an X and a Y, a player, which is made up of an ID, position, and velocity, and then a world that indexes is a map, well, contains things that index everything by the ID, and that gets broadcasted to everyone. So we have an agent and a gen server. The agent holds the state of the world, and every time you make a move, every time you move, your client is going to send its positions, which updates the state in the agent. And this only happens if you've actually moved. If you haven't done anything, then no traffic is sent. And then we also have a world broadcaster, which is a gen server. And this reads from the agent the state of the world. And if the state of the world has changed, then it will broadcast a message out to all of the clients. This is kind of pretty cool, I think, because it means that the two things are entirely detached. And the gen server is ticking over and sending out the state of the world at a set sequence, which matches up with the game library. So that's pretty much my talk. If you like this sort of thing, I'd like to talk to you afterwards. Yeah, it was just a learning experiment, and I'm glad that there's lots of sheep there. So, thank you.
So a funny thing happened on the way to the conference. Andy wanted me to put another thing together to have on the stand. Well, that's not meant to happen. Anyway, well, this time we'd have 2 Raspberry Pis, one on a biathlon bot. You know biathlon, ski shooting? Well, it's like biathlon apart from the skiing and the shooting. And the other one being the target. And they could talk to each other over the network. And I like to use umbrella apps with Nose projects. A nice way of doing with umbrella apps with Nose projects is to have one application being your nerves bit, which is the firmware bit, and all your other code isn't nerves related at all. It's just, and it'll just pull it in, and you can build your firmware in that one place. This time I had 2 separate things. I thought, well, let's just have one umbrella project, 2 things. What could go wrong? Got the one thing working. Got the sensor working first, which you shoot at, and it goes beep, and then sensor things. That worked fine. Then I got the thing for control for the robot up running. Put it on the Raspberry Pi. Didn't happen. Looked at application. What's the thing for listing your open applications? Probably open applications, something like that. Started applications. Nothing had been started. What was going wrong? Well, config bootloader in Nose is the thing which loads your application on when it boots, and this is how it's configured. Config bootloader. It goes out, looks at configuration, loads it. Umbrella projects by default, as somebody said, it wasn't a question, it was a comment. Bit of a problem with umbrella things. They tend to show the configuration. And so the last one was winning. The bot thought it was a sensor application wasn't there. Didn't work. This is the bit that does the loading. One thing you could do is realize that this mix file is just an EXS file, and you can change all that stuff. So you could just say, let's not do the umbrella thing. or just do the general config, but then you'd have to put the same config in both places, a bit of a hassle. I'd done this last minute, it was Tuesday evening, it was 11 o'clock, who can we bother with that? Another thing to do is realise that it's all Elixir, and all this stuff in there is available to you, and you can use it. You can put your own thing in there, and it's still available to you. Mix, the config's loaded when mix is run, and it's loaded from the mix file you're running it from. So so when you're in the bot firmware, this one runs. When you're in the sensor firmware, the other one runs. Ta-da! So project mix config app, use it. Fantastic. It did actually take me about 3 hours to work that out, but never mind. Bonus, could use it somewhere else. So I want to, when we bind, where the nodes got to talk to each other, need to bind something to addressable. There's no DNS binding to the IP address, but I don't know the IP address in advance because it's DHCP. So receive the DHCP event and do it dynamically. What node name I'm going to use? And then I duplicated the slide. I don't know why. Ta-da! You can define it by config. Hooray! I'm not going to tell you how we broadcast that thing. It's horrible. And I don't actually even understand how it works. Multicast UDP, who knows? Does somebody know? I could talk, yeah? Okay, I'll talk to you later. I mean, what is a group? Anyway, that's me. I'm done.